Hello everyone, myself A.K. Magdoum, working as lecturer, Mechanical Engineering Department, SIT Polytechnic Andhra. Today, in this session, we cover the remaining part of unit number 5, that is CNC Part Programming. Here, we are discussing regarding the 5.3 Introduction to CNC Part Programming. Before start the contents, I request all of you to follow and subscribe my YouTube channel to getting the new lecture and videos regarding advanced manufacturing processes. Today in this session we cover the various lecture contents. First of all, that is the CNC part programming. Next one is the part programming structure and dimensioning system. Next one, that is commonly used various functions, that is G code and M codes. Next one, steps for part programming. That much contents we are covered under the introduction to CNC part programming. First of all, there is the CNC part programming. What is the meaning of CNC part programming? Planning and documenting the sequence of processing steps to be performed on an NC machine. That is nothing but a part programming, CNC part programming. Here, there is a traditional input medium dating back to the first NC machine in 1950s is inch wide puncture tape. Means in a traditional method, there is the one puncture tape is there. Over that puncture tape, there are the so many instructions are which are punched over that tape, and that puncture tape which is used for after you want to run the machine. So that medium which is used for a traditional input given to that machine itself by the traditional method in a 1950. Next, more recently, the use of magnetic tape and floppy disk were used due to high data intensity. So recent certain developments, there are the magnetic tape which are come into use in various industries. Then afterwards, so many developments and maybe the various large data storage requirement of that industry. For that reason, in that industry, they are using the floppy disk or maybe the magnetic tape, that type of data storage devices which are used for large data into that different devices. The methods are of the CNC part programming, that is a manual part programming is there, computer assisted part programming is there, part programming using CAD, CAM and manual data input. So in this way we are easily prepare the various part program according to the job drawing. We are easily prepared the part program. So first of all, what is the meaning of part programming? Next, part programming. Here, there is the introduction of a part programming, that is a group of commands given to the CNC for operating the machine is called the program. It consists of information about part geometry. Next one is the motion statement to give the cutting tool. Next, what is the cutting speed is required to carry out the operation, and what is the feed is required to complete that operation. And last one is the auxiliary functions such as coolant on and off, spindle direction. Means that type of instructions which are given into the form of program, that is nothing but a part programming. Next one, there is the NC coding systems. Generally two types of NC coding systems are there. First one, low level languages, means binary number, binary coded decimal, means binary to binary, that is a one type of coding system is there. Second one is the high level languages, that is a APT, that is nothing but automated programming tools. So basically these two coding systems which are generally used for preparing the part program for the CNC machine, that is a low level language, means that is nothing but a binary to binary coded decimal, and next one is the high level languages, that is APT, automated programming tools. Next one, what is the programming structure? Programming structure is having four basic elements First one is the character, second one is the word, third one is the block, and last one is the program. In the character, that is either there are the various digits are used, maybe the different alphabetical letters are used, or maybe different symbols are also used for under the character. And this is the structure. Word is having a different formatting is there, block is having a different format or different definition is there, and program is having a different definition. But this is the basic structure of a part programming. Next, in the preparation of the part program, there is the dimensioning system is a very important method. Which type of dimensioning system you are used for a preparation of the program, that is very important. Basically, there are the two types of dimensioning systems are used in the CNC machine programming. First of all, there is the incremental systems. What is the meaning of incremental systems? Here you observe one image, here sequence of points are there, and here you observe here there are the all dimensions which are look like a continued type of dimensions are given for that object itself. Means this one is the first hole having a 30 mm distance, next one is the sudden dimensions are started from the next previous axis. Means there is the incremental way of dimensioning method is there. Here one drawback is there, if any error is found at the time of given the dimensions, that should be accumulated at the end, and there is the last hole having a shift, last hole might be chances to shift for the unnecessarily extra distance. So that is the drawback. Here you can easily observe when the print show dimensioning going from one location to the next, point to point positioning, dimensions given from the tool's current position to the next location. Means what? Here this is the first dimension, second dimension is suddenly begin from the previous one, and third, that is the previous one. In this way, there is a chain type of dimensioning which is used for the incremental positioning system, and this type of positioning or this type of dimensioning system basically used for a point to point positioning system in either drilling operation or maybe the tapping operation. That type of operations generally used for incremental systems. Means one after the another, if you want to carry the various operation, in that case incremental dimensioning system which is generally used. And next one is the absolute system. Here you observe or compare the previous image with this image. You observe here all the dimensions which are started from one origin. Means this one is the 30 dimension is there, next one is the 70, next one is the 110. These are all dimensions which are started from the origin point, either over the y-axis or maybe the x-axis. All dimensions are started from the origin point. Means all the dimension references having its origin. That is the basic difference. While you compare with incremental, in that case one after the another next dimension distance which is directly given over that dimensioning system, and that is the basic difference between the absolute and incremental dimensioning system. Here one more image is there. When many or all of the coordinates on the print are dimensioned from one fixed point. Here we are already one fixed point means nothing but a origin point is there. From that origin point we are given the all dimensions. Here in this both the image all of you observe, there is then you can clearly understood what is the dimensioning methodology or what is the basic difference between the incremental and absolute is there. That point is a xy 0 position or maybe the absolute 0, or that is nothing but a origin point. So meanwhile, what is the basic difference? In incremental dimensioning system, all dimensions which are linked with the previous one, and in absolute all dimensions are given from its origin. That is the basic difference between the absolute and incremental type of dimensioning system. Next, this one is the best example of absolute and incremental dimensioning system. Here this one is the P1 point. Here P1 point is there. This one is this table which is indicating the absolute dimensioning system, and next one is the incremental dimensioning system over the x and z direction over the u and w direction. Here P1 point, here x position is the 10, means x means in the absolute coordinate system there is the diametric value we are consider, and here the diameter of this component is having a 10, so that's why P1 position which is having a 10 mm diameter. Next, all diametrical value which are considered in the x-axis, and z, because this one is the origin point. Here I am showing in this image, this one is the origin point, so that's why z is having 0. But while you compare with the incremental dimensioning, P1 is the 10, no doubt P1 is the 10, because we are considering the x-axis dimensions are the diametrical values, and while you consider the W, that is also same, that is a 0. But while you take the example of point number 2, that is P2, here there is the x is the 10, no doubt diameter of the workpiece is having a 10, so that's why x is a 10 is there. And while you taking the dimension of a z, means from this origin point, the dimension in the absolute coordinate system or absolute dimensioning system, there is the 10, that dimension, that is a minus 10, because this one is the origin point, and while we shifted towards the left direction, in that case minus z value which is given over that absolute dimensioning system. But while you compare that P2 point with the incremental coordinate system, here there is the x is the 0, or in the case of u, that is a 0, you observe here. Next, but w is the minus 10. That is very important. Here no need to give the there is the repeated values, or maybe because there is the diameter is the same, P2 and P1 diameter is the same, but only there is the shifting of the dimension towards the minus 10. So that's why whenever P1 here tool is there, then next tool which is shifted from P1 to P2, but the diameter is the same. So that's why in an incremental dimensioning system, that should be considered as it is. So here no need to give the dimension of u over the incremental dimensioning system. Next, P3 is there. What is the dimension of P3? Here diameter of P3 is the 20. Here x dimension is the 20. Next, z is the minus 10, because P3 is here, so distance is the 10, so that's why minus 10, that is the absolute dimensioning system. Next, P3 in an incremental dimensioning system, there is the diameter is the 10. How it is 10? Because we are already our tool which is having a position number P2, and this tool which is shifted from P2 to P3, so that's why P2 is having a dimension of 10 plus 10, that is nothing but a 20. So that's why here directly we mention the diametric value, that is a 10, means no need to give the actual dimensions. So that is the basic difference between the absolute coordinate system and incremental dimensioning system. So in this way we are preparing the coordinate table for absolute dimensioning system and incremental dimensioning system. Here in this example I am given you one practice job is there. Here all of you prepare one absolute and incremental dimensioning coordinate for the x and y coordinates, or maybe the x and z coordinates, u and v coordinates for absolute dimensioning and incremental dimensioning. For that purpose, all of you prepare the dimensioning system for this particular job itself. So this is the actual dimensions which are given in this image and drawing. This one is the origin point having a diameter of 20, next one is the 30, next one is the 40, and last one is the having a distance of 15, 8 and 18. These all dimensions and diameters are given for this job. According to these dimensions, all of you, there is the homework I am assigning to you. All of you prepare the absolute coordinate system and incremental coordinate system for this particular job with reference to previous one. Next one, definition of programming. Here, what is the definition of programming? All machining data is compiled and where the data are translated into language which can be understood by the control system of machine tool. Means what? Whatever the programming codings are there, programming languages are there, or maybe the programming instructions are there, that should be compiled, and that data which is translated into the language which is understood by the control system of the machine tool. Means what? That machine having its own controllers for that machine. Basically, in an industry, there is the Fanuc controller is there, Siemens controller is there. According to that controller system, we are preparing the program, and that program which is fed to that machine. Fed to that machine means what? We are translated into the language which is understood by that machine controller itself, and then afterwards we are actually carry out the various movements of the tool, various motions of that spindle, that should be given into the form of certain different instructions, and then afterward machine actually having a different movements. So that is nothing but a programming, or in short, we generally use the word while talking regarding the CNC programming. Programming is the nothing but set of instruction which is understood by that control system. That is nothing but a CNC programming. In short, means what? Whatever the set of instructions we are fed to that machine, that should be clearly translated into the understandable control system or understood by that control system. That is nothing but a programming. Next, in that programming languages or instructions, what we are given, that is the first one, that is the machine sequence. Means what? Classification of process, tool start point, cutting depth, tool path, etc. Means regarding the machine sequence, we are given the certain instruction into that programming code. Next one is the cutting condition, that is the spindle speed is there, feed rate is there, coolant on, coolant off, that type of conditions regarding the cutting of the workpiece material. Related to that, there is the certain instructions are given into that programming languages. Next one is the selecting of cutting tools. Means what? Here there is the various tools are required for various different operations we want to perform over that component. For that reason, which operation you want to perform, according to that we want to call that particular tool for that particular operation performed over that component. For that reason also, there is the different selection of a tool is required, and that should be done with the help of, there is the given the set of instruction or different coding languages into that program, and according to that feeding the instruction to that machine itself, that machine that should be called according to that set of instruction, and different tools are come into contact with that workpiece surface and carry out the machining operation over that component. So this is the all about definition of programming. Next one, what is the programming structure? That is very important. Programming structure means what? Here there is the first there is the program start is there in that block 1, block 2, up to there is the block 31 or infinity blocks are there, and last one is the end of block. Maybe it is called in short the program, there is the EOB. EOB means what? End of block, or maybe the we are generally called the it is end of program. But in the program there is the EOB, it should be written into that program. EOB means what? End of block. Next, in that block, what are the contents? There is the sequence number, no doubt N002 is the sequence number. Word means what? G01. Word 2, X12.0 means what? There is the word 1, word 2 means what? That is the different addresses or different values. Means G01 is the linear interpolation. X12.0 means what? Linear movement in a X direction. In this way, there is the addresses and values which are given under the word. First of all, there is the block. Under the block, there is the sequence number is there, word is there, word 2, word 3, word 4, that type of words are actually used. And that type of words means nothing but addresses are there, different values are there. And this is the actually programming structure of a CNC programming. So this is all about the programming structure. Next one is the one by one we are discuss regarding the what is the meaning of block, what is the meaning of word, what is the meaning of addresses, in the which are consist CNC program which is consist of blocks, words and addresses. So we will discuss in this session what is the meaning of block, word, addresses, or maybe the so many different contents which are required to preparation of the program. First one is the block. Block means a command given to the control unit is called a block. Block means what? There is the what is the instructions are fed to that machine, and what type of command you want to feed to that machine. That is nothing but within one block you are feeding to that control system, and according to that block, then machine which is actuated and carry out the different motion, different movement by that machine itself. Next one is the word. A block is composed of one or more words. No doubt in a previous slide we observed the one structure of the CNC programming. In that there are the so many words we are using for the completing the program for that operation. In that there are the so many instructions we want to give the complete one operation. For that purpose, word is the block is composed of one or more words. No doubt a word is composed of an identification letter and series of numbers or numerals. Example, the command for feed rate of 200 mm per minute, that is F200, means F is the address word or address letter is there, and 200 is the numerals, and which is required means what is the feed given to that programming for that fed to that instruction to that machine itself, that is F200. In short, we are mentioning to that programming code, that is nothing but a word. Next one is the addresses. What is the meaning of addresses? The identification letter at the beginning of each word is called addresses. Here in this example of F200, here F means what? What is the F stands? F stands means feed 200. In short, this F means what? That is the one address which is a clearly identify the letter, or it should be clearly understood by that control system of that machine. The meaning of F, which is already recorded into that control system. While F address word is used, the F means what? That is a feed for that machine itself. So in this way, there are the different addresses, word, blocks which are required. Here, the meaning of addresses is in accordance with the EIA, Electronic Industries Association standards RS-274D. The most common addresses are listed below. Here, so many addresses which are required for a preparation of the different programs. But best example here, all of you observe in this slide, is the F200. That F200 means what? F is the address word. That is very important. It is clearly indicating the F means feed. So that is a simple way. Here, that type of, there are the various addresses are there. We are listed over here. First one, there is the N. What is the function of the N? Address word is the N. What is the function? N means that machine itself understood the meaning of N is what? That is the sequence number. Next one is the G. G means what? That is the preparatory function. Next one is the coordinate word. That is the X, Y, Z. In which coordinate you want to move the your table, or you want to move your tool. That should be clearly different addresses you want to mention into your program. Then and then only that machine control unit, that should be clearly understood. Either you are using the X, Y or Z, in which direction you want to move, or you want to give the movement to that machine itself. According to that, you are basically use the different address words like a X, Y and Z. Next, parameters for circular interpolation. That is I, J, K. Alphabetical I, J, K words are generally used for various circular interpolation. Next, feed function. We are already observed one example like a F200 in a previous slide. That type of example is available. In that, F means what? That is a feed function. Next one is the S for spindle function, T for tool function, M for miscellaneous function. There is the best example which is given under, in this slide also. Here N20, that is the N is the sequence number. Next G01, what is the meaning of G? G is the preparatory function. What is the meaning of X20.5? X is the coordinate word. F200, F is the feed function. S is the speed function. M is the miscellaneous function. So in this way, there are the various words or addresses which are used in the programming coding languages, and that should be understood by that control unit itself, and according to that instruction, that control unit give the or translate into or give the instruction to that machine components, like what is the speed required. Yes, 1000 means what? There is the speed 1000 RPM is required to carry out the machining. So that type of machine movements or spindle movements which is given to that program for that carry out the operation. Next, explanation words. There is the sequence number. We have discussed that part. N address. The sequence number is used to identify the block. It is always placed at the beginning of a block and can be regarded as the name of the block. The sequence numbers need not be consecutive. The execution sequence of the program is according to the actual sequence of the block and not the sequence of the number. That is very important. Whenever, if any error you are getting at the time of machining, how you can found that error? Because if you don't mention the n sequence numbers into that programming block, it is very difficult to find out that block where it is actually found the error. So for that reason, there is the block addresses or sequence numbers which are very important to easily find out. There is the where actually you are getting the difficulties to perform the operation over that machine itself. For that reason, there is the sequence number which is given at an initial position to identify the block. For that reason, it is very important. Next, preparatory function. That is nothing but a G addresses. A preparatory function determines how the tool to move the programmed target, means related to tool movement. There is the preparatory functions having a different meanings are there, like a G00. What is the function of G00? Point to point position at a rapid feed. Next, G01. What is the meaning of G01? Linear interpolation. G02, circular interpolation clockwise. G03, circular interpolation anti-clockwise. G40, cutter compensation cancel. G41 means what? There is the all preparatory function having its own set of languages, set of coding languages are there. And that preparatory functions or G addresses which are used into that program for the functioning these type of different operations into the program. So that's why there are the so many G addresses which are listed over here up to G90 and G91. G90 for absolute dimensioning is there, G91 for incremental dimensioning is there, or maybe the remaining other cutter compensation, milling and cutter cycle, drilling and tapping cycle. Means all the machining related to tool movements, there is the preparatory functions are very important, and that should be used into the preparation of the program. Next, coordinate word. No doubt X, Y, Z, that are the coordinate words or addresses which are generally used for that preparation of the program. Here one example is given. Here x100 and y minus 200. Here before that I am discussed, there is the meaning of x100 and y minus 200. There is the target point of the tool movement, means absolute dimensioning system is there, or maybe the incremental dimensioning system is there. Which type of dimensioning method you want to follow, that should be required to mention at an initial stage. Then afterwards machine movements are carried out. If you using the G90 means what? There is the absolute coordinate system you want to follow, or in some cases or in some programs if you use the G91. What is the meaning of G91? There is the incremental coordinate system or dimensioning method you want to follow into that program. So that's why there is the either it is absolute or incremental dimensioning method you want to follow. That should be clearly mentioned into the form of there are the different G addresses like a G90 and G91. Next, there is the best example of x100 and y minus 20, minus 200 represents the movement to 100 and 200. Whether the dimensions are absolute or incremental, will have to be defined previously using G90 or G91. I am discussed regarding that G90 and G91 in this session also. There is the G90 is related to absolute dimensioning system and G91 is related to incremental dimensioning system. So that type of codes you want to mention at an initial stage of the programming. So that's why then and then only there is the throughout program which should be follow. There is that type of dimensioning system. Otherwise, if you cannot mention the there is a which type of dimensioning method you are using for the preparation of the program, then there is the machine having no mind. So in that case, there may be a chances to damage the machine. For that reason, there is the clearly mentioned the what type of dimensioning method you are following to prepare the program. That should be clearly mentioned at an initial stage or previously into that programming block. Then and then only machine is easily understood and control units are follow that path only. Next, parameter for circular interpolation, that is I, J, K words are there. There is the numerals following I, J, K are with respect to X, Y and Z components of the distance respectively. Means there is the circular interpolation, there are the various codes are actually used, means arc of the distance is there, how much radius is there, that all dimensions with respect to X, Y and Z axis. There is the I, J and K addresses which are used for a circular interpolation. There is the spindle function, there is the S address is there. Here you observe one example how we are calculating the cutting speed or spindle speed. There is a surface cutting speed by 1000 divided by pi into cutter diameter. In this way we are easily calculate the spindle speed. Then there are some standard materials having a common cutting speed which are mentioned into this table also. Here HSS for alloy, AL alloy, next brass, cast iron. There is having different work materials are there and defining the different common cutting speed also. The best example of mentioning this address, that is S2000 represents a spindle speed of 2000 RPM. Means we are using the S2000 word into that program and easily we are getting the 2000 RPM at the time of machining of the spindle. Next one is the miscellaneous function. There is the M addresses. That is a very important functions. The most common M functions which are listed or which are mentioned in this slide also. There is the miscellaneous function is a program to control the machine operation other than for the coordinate movement. Means in a previous slide all of you observed the G word or G address, that is related to the tool movements, axial movements are there. But whenever there is the different machine operation movements are there, like M00 program stop is there, M03 spindle rotation clockwise is there, M04 spindle rotation counterclockwise is there, M05 spindle stop is there, M06 tool change is there, M08 coolant on, M09 coolant off, M10 clamp, declamp. There is the so many miscellaneous functions we are using for a preparation of the program. All of you, I request all of you to list out all the G and M codes, because while you want to prepare the program, these are all addresses which are required for a different operations or different movements of the tool and different machining conditions which are required for the carry out the machining. So that's why I am request all of you to list out all the programming codes which is mentioned into this video or in this slide, that is a G code and M code, or maybe the G addresses and M addresses, that is a preparatory function and miscellaneous functions. That is a very helpful to prepare the program for the CNC machine. Next one is the steps for part programming. What are the steps? First step is the very important. Study the part drawing carefully. Before start the programming, prepare the programming, there is the carefully understood the what is the drawing is there, what is the part drawing is there, what are the operations or what is the actually dimensions are mentioned over that drawing is there. That should be clearly understood at the initial stage. Then you move further next step. Otherwise, if you don't understood the part drawing, then it is very difficult to prepare the part program. Then next step is unless the drawing dimensions are CNC adapted, select a suitable program 0 point on the workpiece. The tool will be adjusted to 0 point during the machine setup. Means what is the dimensions are given into that drawing, according to that there is the select a suitable program 0 point. Program 0 point means what? There is we are discussing in the previous session also. Program 0 means what? Where actually tool which is a touch with a workpiece surface, that is nothing but a program 0, and that tool will be adjusted to this 0 point during the machine setup. Means that is we are easily find out the machine work 0, and then afterwards there is the next step will be carried out, determining the machining operations and their sequences. Once you read the drawing carefully, then defining the program 0, then suddenly next step is the what type of operations they want to perform over that component. According to that, there is the sequence of operations are defined, and that sequence of operations we are easily defined while there is the component you clearly observe and what type of operations you want to perform. Next one is the select cutting tools and determine spindle speeds and feed. By various calculation we are determine the various cutting speed or maybe the feed is there, and there is the according to that cutting speed feed we are easily select the various tool for various operations. That is the next step. Next one is the write program. Write program means what? In this there is the translate machining steps into program blocks. Means what? What is the instruction you want to feed to that machine? What type of movements are required? What type of motions are required? That all instructions which are fed to that machine into the form of programming codes. That is nothing but there is the set of instruction, that is a part programming. Next, what is the requirement of that? If many solutions are possible, try the simplest solution first. It is usually longer but better to proceed in this way, because there is the best one is the so many solutions are available in front of you, but try the simplest solution first, because there is the easily that problem we are sort out, or easily we are preparing the program for that preparation of the component. In that case there is the unnecessarily waste of time is reduced, and that should be fulfill the requirement of that dimensioning of the component. So that's why that F step, that is very important. Next, prepare tool chart or diagram, measure tool geometry, that is what is the length is there, what is the radius of that tool is there, and note down the all dimensions of the tool chart. Next one is the clamp workpiece and setup machine. Means according to once you prepare the program, then the next step is the clamp workpiece into the chuck and set the machine. Set up the machine means what? There is the machine having its origin position, means nothing but a machine 0 position is required, because from machine 0 position to the work 0 position there is the rapid traverse is there. So rapid traverse means what? There is the aerial travel of the tool is there. So that's why we are generally use the G00 code for that type of travel. So this step is very important. There is the setup of machine and clamp the workpiece. Next one, enter compensation value if necessary. Tool compensations are there. That compensations value we want to mention into that program itself, because then and then only you are manufacturing the accurate and precise dimensioning job with the help of that CNC machine. Next one is the check and test program. That is, it is good practice to dry run the program. Means that CNC machine having a one feature. With the help of that feature, there is the dry run feature is there, and with the help of that dry run facility, we can carry out the operation without the workpiece. Dry run means what? In that chuck there is the no workpiece available. Workpiece is available, and we are only carry out the tool movements over that workpiece surface, how it is looks like, and that graph which will be plotted over that LCD screen or maybe the display of that CNC machine. Without the cutting tools, means without cutting tool, without workpiece, we are carry out the dry run, and that should be getting the clear idea regarding the how the tool path, how the tool movements will be takes place over that CNC machine. Then if necessary to correct the program or edit the program, and again check it, and then afterwards you finalize this program is correct for the machining of this component. So these are the various steps, and then last step is the start machining. Once these all A to J steps which are covered, then last step is the start the machining. Press the button and start the machine. Then afterwards you already clamp the component, and then afterwards the tool which is come into contact with that workpiece surface and start the machining. This is the various steps which are required for the CNC part programming. Next one is the part which is related to this CNC part programming, which is covered into the next session. So this much contents related to the CNC part programming which is covered into this session. Thank you very much.